Welcome to the presentation of XRTwinScape. Today, industrial training faces a triad of challenges: cost, safety risks, and the complexity of creating realistic training scenarios. XRTwinScape is a groundbreaking solution designed to tackle these exact problems. It is a comprehensive platform for industrial training that combines three key innovations: the easy and realistic digitization of work environments, an intuitive system for lesson authoring, and immersive lesson playback through extended reality devices. Our goal is to bridge the gap between physical workspaces and digital learning, making high-quality training accessible to everyone. This project was realized as a winner of Open Call 2 of the European project XR2Learn. XRTwinScape has been developed by a dedicated consortium that brings together distinct expertise. First, we have Formamentis, the coordinator and pilot of the consortium. They are a recognized leader in industrial training in Italy, operating multiple offices and specialized facilities across the country. Supporting the scientific backbone is CERICT. As the research partner, they were responsible for the research and development of the digital scanning technologies used in this project. Finally, the technical implementation was carried out by Picaresque, an award-winning XR and video games development company that handled the core development work. Together, this trio covers the full spectrum from pedagogical needs to advanced rendering technology. The XRTwinScape ecosystem is designed to let trainers create immersive lessons in a digital twin of their own workspace without needing any 3D modeling skills. The solution is composed of three parts, starting with the web-based dashboard. This is the command center, where trainers can manage existing immersive lessons, create new ones, and initiate the digitization process. Traditionally, creating a 3D environment requires expensive laser scanners and expert artists. With XRTwinScape, the process is incredibly simple. To create a digital twin, the trainer essentially shoots a 10 to 15-minute video of the real environment. As you can see here, the trainer simply walks around the space, ensuring they cover the entire area while focusing on interesting details. Once this video is uploaded, the digitization process is triggered directly from the dashboard. Powered by advanced Gaussian Splatting technology, the system automatically reconstructs the environment in just 3 to 5 hours. This speed and ease of use are what set XRTwinScape apart. Once the environment is digitized, we move to the XRTwinScape editor. This is a powerful, web-based application designed to transform those static digital twins into engaging, personalized learning experiences. The editor is built on a web-based rendering engine that displays the digital twin in high fidelity. Trainers can fully explore the environment in 3D and use various tools to edit the scene. The core feature here is enrichment. Trainers can seamlessly integrate contextual, multimodal information, including text, images, audio, and video, directly into the 3D space. These are placed as digital pins or annotations throughout the environment. The user interface allows for deep customization. Trainers can modify the content, position, and crucially, the variance of each annotation. An annotation isn't just a static pop-up. It can change based on three specific factors: skill, emotion, and expertise. Thanks to this adaptive system, the lesson automatically tailors itself to fit the profile of any user, ensuring the training is neither too easy nor too difficult. After the lesson is published, it becomes available in the VR player. This is accessed using common VR headsets like the MetaQuest 3. Before the trainee begins, there is a setup phase using the operator UI. Here, the trainer can manually select the target skill, emotion, and expertise levels to tailor the specific session for the incoming trainee. When the trainee puts on the headset, the experience begins. A timer starts, and they are free to explore the surroundings using the headset and controllers. Their goal is to locate the annotations pinned within the digital twin. The lesson is structured into specific activities, each with a clear objective displayed on the user interface. Once the trainee locates and opens all the annotations required for an activity, it is marked as complete. The system then unlocks the next activity, causing new annotations to appear in the environment. This step-by-step progression continues until the last annotation is opened, marking the lesson as fully complete. We understand that not every training scenario allows for a VR headset. As an alternative, we implemented a web-based player. This version is designed for trainees who may be less inclined to use immersive technology or simply lack access to the hardware. The digital twin environment and the lesson contents are identical to the VR version. The only difference is the interface. Here, the trainee uses a standard keyboard, mouse, and monitor to navigate and experience the lesson, ensuring accessibility for all users. To validate our approach, we entered the final phase of the project, validation. We conducted a large-scale evaluation involving 164 participants across diverse demographics. The study involved 4 distinct test sessions with users who had never used XRTwinScape before. We gathered data through a series of questionnaires administered both before and after the lesson play. Our specific focus was analyzing the impact of the delivery medium, VR versus web, on learning outcomes and engagement. The comparative analysis revealed fascinating results. While both modalities were effective for learning, the VR client demonstrated significantly higher scores in perceived utility, ease of use, and behavioral intention. In addition, users expressed a strong willingness to reuse the tool and to recommend it to others, further confirming that the immersive element plays a crucial role in user engagement. In conclusion, the pilot experimentation findings underscore the specific advantages of immersive VR. It facilitates industrial training that is not only effective, but safe. XRTwinScape offers distinct insights into how we can transform vocational education. Furthermore, the technology we have built is highly versatile. It can be easily transferred to other critical sectors, such as healthcare, cultural heritage preservation, and even gaming. Thank you for watching.